All right, so really quickly I'll go through this one, guys. This is short, and hopefully you can see this is the exact same skill that we did in exercise 4C. Just maybe a different context, right? In 4C, we're talking specifically about area under the curve. Here we're talking specifically about the value of a definite integral. So definite integral means it's got these boundaries, right? These constraints. And so if it's a definite integral, that means when we integrate, we don't need the plus c. Okay, so let's go ahead and perform this one. Firstly, the 5's going to hang out the front. Now, one way we can treat this as well, if you look in your notebook, I've listed all of the properties. So you can apply any of those if the constraints are suitable and if the function is suitable and so forth. What I'm going to do here, I'm going to pull 5 out the front and show you how it works out the same anyway. All right, so remember it's a multiple, it's a product. I'm going to pull that right out the front, and then this is going to be the integral up form. So what I've got there then is I've got the 5 just hanging out the front, and we're going to have x to the 4 on 4 from 0 to 2. Okay, so we're applying the fundamental theorem of calculus. We're at this stage after we've integrated f of x. We've got this big f of x function over this interval, and the 5 is just going to multiply whatever our final answer is. All right, we're going to plug in the 2. All right, so what it evaluates to is 2 to the 4 on 4. Take 0 to the 4 on 4. All right, so this is what we obtain when we substitute the 2 in. This is what we obtain when we substitute the 0 in. And then let's evaluate that, right? 2 to the power of 4 is going to be 16. All right, 16 divided by 4 is going to be 4. And this one is just going to be 0. 5 times 4 is 20. Alright, so this definite integral evaluates to 20. Now what are the required steps that you need? So here, this, the integral statement, you need the integral, you need the substitution, and then you need the answer. So there's always 4 things that you need listed. Alright, the rest of the working out is not essential unless, like in this next circumstance, it asks for an exact answer and it's involving E and Ln. Okay, any questions with that one? You can see it's the same skill as 4C, hence why we do them sort of back to back. All right, on to here, e to the 2x. So when we integrate e, it goes to 1 on a, e to the ax, right? And our boundary is from 0 to ln3. Okay, so that's the first step. When we integrate e to the ax plus b, it goes to 1 on a, e to the ax plus b. So we've moved from here to here. Okay, on to the next one. We're going to substitute in the upper and the lower boundaries. So we've got half e to the 2 ln3. Take away half e to the 2 times 0. Let's put that in brackets. And let's put that in square brackets. Alright, so we're at this step, and let's process that. We're going to have to do that manually, because you could put it in your calculator, but it's going to come up with a decimal, right? We want the answer in exact form. So this e to the 2 ln3, the first thing that we're going to do is move that 2 up to the top of the ln3, alright? So that it's like this, ln3 squared, which is ln9. So this part's simplifying to e to the ln9. I'm going to do it over a series of steps. So half e to the ln9. And then take away, we've got half e to the 0. All right. Now e to the lnx simplifies to x. Therefore, e to the ln9 simplifies to 9. We've got half of 9. Take away half times, not 0. Okay, lots of people will go e to the 0, that's 0. Any number to the power of 0 is 1. Alright, so this is going to evaluate to 1. So we have 9 times a half, take away a half, we've got 8 on 2, 4. Alright, so this would actually be 1 if you were to put this in your calculator. Because it's a rational number, it's going to pop out with a nice answer for us. But we've probably in this question, it'll be very clear, and it'll want you to show all of these processes so we can demonstrate the understanding of logarithms and exponentials. All right, so that's enough to get 4G done. Probably some people have made a start on it already. Are there any questions in particular? All right, what I'll do today is